The universe is absurdly big. There are more stars than grains of sand on all the beaches of Earth, trillions of planets, millions of possible Earths. Mathematically, life should be everywhere. So why is it so quiet? This is the Fermi Paradox. The observable universe stretches 90 billion light-years across. Inside it, at least 100 billion galaxies. Each galaxy with billions, sometimes trillions of stars. Our Milky Way alone holds about 400 billion suns. If you scooped up a handful of sand, there would be about 10,000 stars for every single grain in your hand. And now we know planets are not rare at all. Many stars host multiple worlds, and billions could be orbiting inside the habitable zone, where liquid water and life are possible. Even if life began on just 0.1% of those worlds, the Milky Way alone should have millions of planets filled with living creatures. Some of them older than Earth, some of them with billions of years of head start. So where are they? Here's the paradox. The Milky Way is about 13 billion years old. Earth, by comparison, is just over 4 billion. So life had billions of years to emerge somewhere else first. And once a civilization develops space travel, it wouldn't even need to be fast. With self-replicating ships that can last thousands of years, a species could spread across the entire galaxy in only 1 to 2 million years. Some scientists even calculated that if we had ships lasting just 1,000 years, humanity could spread across the entire Milky Way into million years. That may sound long, yet compared to the age of the galaxy, it's less than 1% of its lifetime. And the Kardashev skill shows how far they could go. Type 1 civilizations harness all the energy of their planet. Type 2 civilizations harvest the full power of their star, maybe by building a Dyson Sphere. Type 3 civilizations control the energy of an entire galaxy. To us, they look like gods if even one such species existed. Their fingerprints should be obvious. Stars dimming from Dyson Spheres, massive engineering projects glowing in the dark. Yet the sky is silent. This is the heart of the paradox. The math screams that the galaxy should be alive with activity, but our telescopes see nothing, no megastructures, no signals, no alien highways stretching across the stars. Enrico Fermi asked the haunting question over lunch in 1950, where is everybody? One possibility, life is extremely rare. Maybe the jump from chemistry to biology was a 1 in a trillion accident. If that's true, we might be the only candle burning in an otherwise dark cosmos. Another answer, life is common, but intelligent, technological life is not. Earth hosted life for 3.6 billion years, but only in the last few 100,000 years did humans appear. For most planets, evolution might stop at microbes or animals. Dinosaurs ruled Earth for 150 million years without building radios or rockets. Maybe intelligence is the real anomaly. But maybe the universe is full of civilizations that just don't last. On Earth, 99% of all species have gone extinct. Civilizations might rise, colonize a few systems, and then collapse over and over, never lasting long enough to meet each other. Rotting away on distant worlds we haven't found. Maybe we just missed them. After all, intelligent life on Earth has existed for only about 250,000 years. And for barely a century, we've had the tools to send signals into space. If alien empires rose and fell millions of years ago, our tiny window of technology might simply be too short to ever overlap with theirs. And what if advanced life is out there, but ignoring us? Think about the smartest squirrel you can imagine. No matter how hard you try, you could never explain the internet, or politics, or space travel to it. From the squirrel's point of view, humans cutting down forests must seem like madness. But we don't do it because we hate squirrels. We do it because we want resources. To a Type 3 civilization, we might be those squirrels. Too small, too primitive, too unimportant. They could wipe us out in a second, not out of malice, but out of indifference. But maybe the truth is stranger than fear. Perhaps aliens simply don't care about space travel. Why waste millennia colonizing galaxies when there are better options? One theory is the Matryoshka brain, a megacomputer built around a star, so powerful that an entire species could upload its consciousness and live in a simulated paradise for trillions of years. Why risk the dangers of space when you can live forever in virtual heaven? Or maybe our methods of communication are embarrassingly primitive. Imagine sitting in a cabin with a Morse code machine tapping away for years. No one answers and you feel utterly alone. But outside, people are using smartphones and satellites. To them, your signals don't even register. Maybe that's us banging rocks together while the galaxy hums with conversations we can't even perceive. And even if we did meet them, communication might be impossible. Imagine trying to explain human society to a squirrel. To us, it lives in a tree and gathers nuts. What more could it possibly need? In the same way, alien motives and technologies might be so far beyond us that we'd never truly understand them. So what's the truth? Are we alone? Are civilizations doomed to collapse before they meet? Or are the stars filled with wonders we're too primitive to notice? There is one idea that overshadows them all. A terrifying possibility that says something is stopping civilizations, a mysterious barrier that prevents them from spreading among the stars. Scientists call it the Great Filter, and that is the mystery we'll explore in our next video.